Hello, welcome to this new session. In this new session, guys, we will be focusing on the virtual machine, the VM, and how it will execute the bytecode. So as you see here, this is the whole architecture of the Ant language. This is an Ant pipeline. For the front end, we have a compiler, and then we have for representation we have bytecode, and for execution we have the VM or virtual machine. So the compiler, we will read the source code and then it generate a bytecode for that source code, and then it pass that to the virtual machine for execution, for side effect. So in this session, guys, we will just focusing on two parts, the bytecode and the VM. So let's explain more that. As you see here, we have an Ant developer. It decides to write a simple program. He is just learning our Ant language. So the simple program that developer write is just a print 10, some value. So after the developer executes the command to interpret that code, it uses Ant and it passes a name of the file, of the code. So then the compiler will read that source code and then it generates this bytecode. As you see here, we have three instructions. The first one, op constant, it will load a 10. Then we have op print. As the name suggests, it will print the value 10, and the final instruction is the return instruction. It simply end the execution or halt the VM. So after that, this bytecode generated by the parser or the compiler will be passed to the VM, and then VM will execute instruction by instruction, and then it will return at runtime the output to the developer. So the question that we need to pose in this video, it's what we need to develop a virtual machine or VM. So we have three things. The first one, we need a structure that stores the bytecode. This structure will be accessible by the VM. Also, we need some kind of tracker that track the instruction that the VM need to execute, and then the VM should have some stack to operate, some stack to do operation. So I put here an example of a execution flow for the simple program print 10. As you see here, we have the bytecode. This bytecode has opconst 0 to define that this is the index in the table of constant, and we have the value 10 in the position 0. After that, we have the other instruction, op print, and then op return. The state of the stack of the VM, and we have here the instruction pointer. This is our tracker that track where the VM and what the instruction that VM will execute. So the VM, it will see opconst, then it load 10. So as you see here, this the head of the stack, it is increased by 1. So after that, the IP is increased to the next instruction, op print. Then the VM, it pop the value 10 and it returns to the developer, to the user. So finally, the IP is incremented also by 1, and then the VM sees op return, then the VM it will end the execution and it stops. So here, as you see, the VM, it will load in this example, it will load the constant. Here it will print the value, and finally it will halt or end execution. So we will jump to the code and we will do build the structure that VM needs and all the things that lets the VM run the bytecode. In this video, remember guys, we will just focus on the VM and the bytecode. We are not focusing on the parsing part or compiler part. So for the purpose of simplicity, we will just hard code the bytecode of this program, print 10, and then we will see how the VM will interpret that. So let's jump to the code. So let's continue building this project. First, we will create a VM.header file. We will define the guards as usual. Okay. And we will add that. And so let's start. First, we will create an enumeration for the VM response. Interpret result. This enumeration help us know which type of error happens, if it is a compile time or a runtime, or it is a success. So interpret compile time error. Okay, interpret runtime error or interpret success. Okay, so let's build the structure of the VM. Type def struct, and we will call that VM. We will have another structure called chunk that stores the bytecode and constants. Also, we will have a instruction pointer that track the instructions. I did this type because, as you know, the bytecode has the length of 1 byte, so that's why I did a pointer to an int of 1 byte. So also we will have a stack that stores some value. We'll do some stack have a maximum max size. We will define that macro. And finally we have a pointer to the top of the stack. Okay, so we will create that macro, define stack max size. I did that arbitrary, you can do whatever you want, so make the value large enough. Okay, then we will need some functions to implement. First one is init the VM. We need to initialize the state of the VM. Then we need to free the VM if it stops executing, and then we will have a function that interprets the source code, and it will return the interpret result. Okay, that's good. Interpret result. Okay, that's fine. So after that we need to create these two structure, the chunk structure and the value that needs to be stored in the stack, on the stack. So let's jump to create this simple structure value. So I will create a value dot h header, and we will also define the macro as usual, and if so for the sake of simplicity we will create a structure called value, so we will name it value. So now let's jump to create the chunk that store the bytecode and constant. Chunk h will have also this macro if not define and okay. So first of all we will create an enumeration that enumerate the operation code. In this session we will focus only on 3 opcodes, like opconstant, opprint, and finally opreturn. So after that we will create the structure of chunk. We'll create the structure struct called chunk that store. It's a dynamic array. We'll track the capacity, also we'll track the number of elements in that array, and also we will store the code, the bytecode, and image code. Also we will need to have another structure that store all constants and then also we'll track the number of lines that will help us in for debugging purposes. So let's create the fundamental functions that need to be implemented in it chunk, and accept a pointer to the chunk. Then we need a way to write into the chunk, so we'll pass a pointer to the chunk, and then we'll need to give the value and the line of that value. That means this function will be helpful in storing some value in the chunks, or in other words, we'll store the bytecode operation like opconst, opprint, opreturn, and so on. Also, we will have some helper function that write into the constant array. We will give the pointer to the chunks and the value that need to be stored in the constant array. Okay, also we need to free the chunk. Okay, so now what we need is to implement the value array structure in the file of value.h. Okay, let's go value.h and we'll create that structure. So cheap def struct value array. Also it's a dynamic array. Values. Okay, so we need if and the multiple functions like init value array. We will pass a pointer to that, and then we need somehow to write the value into that array, and then we will return its index. Value that will be helpful in the chunk part, because we need that index, and when we get that index we will store it as a bytecode, like the example of const 0 as I showed you in the whiteboard. So let's continue. We need another pointer to that structure. Also we need to pass what's the value that needs to be stored. Okay, we will need some helpful function that just print a value when we pass that to it. Also we need to free the value array, and as you know we will pass a pointer to that. Okay, now let's jump to implement the chunk. So vim chunk points here. We need to include its header. Let's start with the first function in each chunk that accepts as a parameter a pointer to the chunk, and then we initialize its state like capacity to 0, also like count to 0 for the structure that store the bytecode will be null. We need also to init value of the array. We pass the constants. Also we need to initialize lines array. After that we need to write to the chunk some value. We need the byte value and its line. So if chunk count plus 1 is greater than chunk capacity, that means that we need to allocate some extra memory. So I need somehow to use realloc in C. So I need to implement a memory manager that when I call it, it will dynamically allocate some extra memory as I need that. So let's save that, and let's create my memory manager. So as usual, if not define, okay, memory match. Also let's define that one, memory, and let's end this. Okay, let's include command.h, and let's create that function that will pass to it the pointer and the new size. This function will handle the allocation and also the deallocation. So if I call it and I need to free the memory, I just simply will pass 0 to the new size. If not, if it is greater than 0, which means it's an allocation, or it's the allocation of some memory, like shrinking. So let's define some helpful macros here. Grow capacity, that we will pass to it some annulled capacity. Let's use a ternary operator, capacity. If the capacity is low than 8, then we will grow the capacity only by 8, and if it is not, we will grow the capacity by 2 times. Also, we will define another macro that will be helpful to grow an array. We will pass the type of data that will be stored in the array, also the pointer and the new size. So we will use our function reallocate. We pass that pointer and size of type times the new size. Finally, we will define another macro that free a given array. That will be helpful when we will free a chunk or value array or some random array. We pass also the type and pointer to the structure. Okay. And we will pass 0. That's good for now. So let's implement reallocate. Okay, vim memory.c will include memory h void reallocate and size to new size. If the new size is less than or equals 0, we need to free that memory because we are allocating on the heap. Return no. Otherwise, we will return the new. We will use the function, the C function realloc, we pass it to our pointer and the size, and then if this new pointer is null, we need just to abort. We need to exit by one. So let's return this new point. Okay, we've done here. We need a library called stdlib standard library h, and we are done here. So let's go to the common header file and we will add another header that is useful. Common.h. This header is standard def, and also that has some types like unsigned int age or 32 or whatever. So let's save that and go back to our chunk. Okay, let's continue. First of all, we need to grow the capacity of the chunk. We will use the macro that we've created in our memory manager, grow array, and we will pass the old capacity. Also, we need to grow the bytecode array that stores the code. Grow array, and we will pass its type. It's a bytecode, so it's unsigned int 8, and we'll pass the pointer and also the new capacity. Finally, we will also allocate for the line array its for int values, and the pointer of that is 9, and the capacity, it will be the same capacity at chunk capacity. After that, the purpose of the function is to store the value or the bytecode. So let's do that. Code chunk count, and we will add the value. Also for the lines in the position count, we'll add the parameter line, and then we will increment the count by 1. So we have done with the right chunk. So let's pass to the function write constant. That is helpful. We will pass to it the value, and then it write the constant in the array of the constants. So we'll do that. We'll pass the pointer to the chunk, and what's the value that we need to store, and we will use the helper function write value array. We will pass the pointer to the chunk constant array and value. So finally, we will free the memory. Free chunk. Free array, it's 8, and chunk bytecode. Okay, also we will free the lines array. Also we will free value array, the array of constant. And finally we initialize, it stays back. So let's get jump to the value, let's see, and we will include value rich. So let's start by the first easy function. It's the initializer. So array capacity is 0, array count also is 0, and array values it's none. Also we need a function that writes into that array that value. It's like how we implement the chunk one. Array count +1 if it is greater than array capacity. Then we will allocate some extra memory. Array capacity will grow the capacity. We'll use the macro grow capacity, and we'll pass to it some old capacity, grow capacity, and then we will allocate memory for the values array grow array, its type withhold values, and array as a pointer, array values, and then array capacity. Then we will add the value in the values array count. Will increment that later. And we will assign to it the value, and we will return its index position. Okay, let's go and implement print value. We'll pass to it value, because the value for now it's a double, so we will do like that. So finally let's free value array, value array free array value array values, and we'll initialize it. Okay, so let's add some include headers, like we've used the memory manager. Also we've used the printf function, so we need to include standard input header. Okay, so now we've accomplished some. So let's come back to our VM and start implementing the functions needed by the VM.